Assalamu alaikum.
Hello.
Alaikum.
Assalamualaikum.
Walaikum assalam. I just do a quick check for the bell and the share screen, okay?
All right.
Do any of you want to check also?
Can I try to share my screen?
Yes, you can.
Okay, can you see my screen?
Yeah, you can.
So,
Assalamu alaikum, Prof.
Hello everyone.
Hello.
Hi.
Yeah, it's moving also.
okay.
Do you hear it? Okay. And so I put the moderator slide. So, Prof, when the evaluators also join, then we can start. Our time is already its time. Just waiting for the evaluators.
Okay.
Dr. Rita is not there.
Okay. So and the presenter, how we have here Intana Joa, the first presenter, and only one
Presenter.
presenter. All are coming in. No.
Yeah, Miss Intan is here, Mr. Azam is not here, and Miss Nur Saida is here.
Okay.
Dr. Marlinda, okay, I
Still not here.
personally knocked them.
Okay. So thank you, Afrin. Just notify me when they arrive. Okay.
Okay.
Okay. Okay. Thank you so much.
One question. Do you see my PowerPoint window or you see the slide only?
PowerPoint.
Why isn't it changing? I did the step I also.
Afrin, is there all the evaluator? Uh, so we still waiting for other evaluator to come.
Waiting for Dr. Marlinda, Prof. Mr. Azam bin Muhammad, can you please press the button ask for...
Dr. Malinda is here.
Okay, okay, okay.
Mr. Azam, can you please respond to us? Can you respond to us in chat room?
Yeah, he came, he came.
Azam, okay, so I think everyone is here. So can we start now or we have to
Yes,
wait?
we can start.
Okay, so thank you, right?
Oh, Dr. Rika is not here.
Dr. Rika. So Dr. Rika's slot will be after uh, Miss Intan, yeah? Or we can start first and then once Dr. Rika join, so can we rearrange?
Oh, she's
Then,
here. Yes,
okay,
yes, Prof, you can start.
okay. So, uh, hi, good morning, everyone. Okay.
Morning.
So, Assalamualaikum and very good morning to everyone. Thank you for your attending to our conference. Okay, so my name is Laili. I'm from UST Malaya. So I will be the chair session for these sessions. Okay, so ladies and gentlemen, we are about to begin our uh, plenary sessions. Okay, please stand by, and I would like to seek for all your kind cooperations to avoid any virtual disturbance during this live broadcast session. Okay, so if you have any questions, the conference resources personnel here we have the IT personnel ready to attend you at the reception desk. Okay, so before we start, so um, let we begins with the some general regulations about the presentations. Okay. Okay. So I will be the session chair today, and together with the me is Miss Asrin, and the IT personnel here is Nursiada, right? So anything that you have problem with your slide or any technical problem, so you may directly contact to them through the chat box. So here we have the speaker and also for the invited speaker. For speaker, we have 50 minutes presentations and 10 minutes for Q&A. Meanwhile, for the invited speaker, we allocate 25 minutes for the full presentations and followed by 10 minutes Q&A. So our IT personnel will ring the bell when it approach 10 minutes or 5 minutes before end of the presentations. So please be aware about the bell ring. Okay, so without further ado, so I would like to invite our first presenter, Ms. Intan Najwa Humaira, to start the presentations. Or before that, Ms. Intan, would you like to try your mic or I give 1 minute to try your mic and the slide?
Okay.
Okay, the floor is now for you, Ms. Intan.
Okay. Everyone see my slide?
Yes, Miss.
Alright. Okay. Sorry. Sorry. I think. Okay. Now everything's clear. Okay. Can I start?
Sure, can.
Okay. So, Assalamualaikum everyone and greetings. My name is Intan Najwa Humaira and I am from Faculty of Engineering, International Islamic University, Malaysia. So today I would like to present my project entitled The Effect of HNT Addition on Mechanical and Thermal Properties of 7030 polylactic acid polypropylene carbonate blends. So this is the content for today's presentation. Okay, let's start with the introduction. Okay, polylactic acid has
Miss
become
Intan, excuse me, before you proceed, can you change to the PowerPoint format?
yes,
This one, can you change to the slide format?
or slide format. This one is it?
Yeah, this in the PowerPoint, right?
Yes.
Presentation slide. Okay, yes, yeah, yeah, yes, yes. Yeah, at the
Oh,
bottom.
okay. Or
Yes.
cannot open a full view.
Yeah, because we see your here we see it as a PowerPoint. It's
Uh,
possible.
Now
I,
everything clear?
IT personnel, can you please help Miss Intan?
Miss, you can go to the slideshow.
Okay, now I go to the slideshow.
There,
Actually,
Is it clear?
maybe you
uh,
escape first. Try to escape first. Go
Okay.
to the reading mode because you have to set to view in the
Reading mode.
individual window.
yes,
Yeah,
now okay, now okay.
go to the reading mode.
Is it
It
clear?
is it is okay.
Okay. So
So I restart the time.
okay, I continue. So polylactic acid has become an active area of research, especially in biomedical application and also food packaging, because it offers biodegradability, biocompatibility, eco-friendly. It also has excellent transparency and barrier properties. However, polylactic acid is very brittle. Its elongation is less than 10%, which has restricted its application that require a flexibility at a higher stress level. Example of the application that require a flexibility is implant plate. Okay. Meanwhile, polypropylene carbonate also offers biodegradability, biocompatibility, and eco-friendly. However, compared to polylactic acid, it has excellent in elongation. Okay. So previously, we have conducted a study on improving the neat PLA mechanical properties, and we found out that with the addition of 30% of PPC has greatly enhanced the strain value of polylactic acid. However, it's resulted in a decrease in tensile strength. Hence, the aim on improving the tensile strength of the polylactic acid while maintaining its flexibility is a delicate task. Okay. Halocyte nanotube has been reported as one of the alternative on improving the mechanical properties of polymer blends, as previous reported based on previous reported research. It is also biocompatible. It exists in a tubular structure, which around 500 to 1000 nanometer in length and 15 to 100 nanometer in inner diameter. So we believe that the addition of halocyte nanotubes, the incorporation of halocyte nanotubes could improve the mechanical properties of PLA PPC blends. So in this work, we reinforce the HNT in to the PLA PPC blends. Our main focus is to improve the mechanical properties of these blends. Okay, next is the materials and methods. So the material used consists of polylactic acid, polypropylene carbonate, and halocyte nanotubes. Okay, all of these three materials will be blended into by using the internal mixer with a process called a melt mixing method. So the amount of HNT incorporated into the blend consists of 0, 2, 4, and 6 weight percent, which obtained from the design of experiment. So um, then we will produce the sample that consists of the dumbbell shape and also the bar shape. So this figure shows the sample of the dumbbell shape for the tensile test. Okay. Next is we conduct the mechanical properties and also the thermal properties. So the mechanical properties consist of the tensile test, the flexural test, the impact test. And the thermal properties consist of the differential scanning calorimetry. Okay, so this is the result. Okay, figure 1 shows the stress strain graph of 7030 PLA PPC with different HNT content. Okay, when we try to zoom in, we could see that with the addition of 2% of HNT into the blends, okay, there is no significant improvement of of the stress value. Okay, um, but the strain value is is quite high here, around 160%. So with the addition of 4%, the stress value start to increase to around 38 MPa, 38 to 40 MPa, and keep increasing when the amount of HNT increase to 6%. However, the strain value will gradually decrease with the increased amount of HNT. Next, figure 2 shows the average tensile strength and Young modulus of 7030 PAPPC with different HNT content. Okay, for 7030 PAPPC without the addition of HNT, the tensile strength is around 32 MPa with the Young modulus of around 1.26. With the addition of 2%, we could see that there is an increment of the tensile strength and also the Young modulus from 32 to around 39 MPa and from 1.26 to around 1.38 GPa. However, we could see here that further increase of HNT to 6%, there is a slight decrease of the Young modulus and also the tensile strength. However, the value is still much higher compared to the 7030 PAPPC without the addition of HNT. Okay. Next is the average strain of 7030 PAPPC with different content of HNT. We could see that there is a gradual decrease of the strain value as the amount of HNT increase from 0 to 6%. Okay, here we could conclude that although the strain value of 7030 per APPC decreased with the addition of 2, 4 and 6% of HNT, the value are still much higher compared to the need per A. Since our main aim is to improve the strength of the need per A, but at the same time we want to improve the strain of the need per A, but at the same time want to maintain the strength of the blends. So when we compare to the need per A, okay, we could see that for need per A, the tensile strength is 68 MPa. But with the addition of 30%, the tensile strength will drop to 32. Okay, and then when we incorporated with the HNT, we could see some improvement in terms of its tensile strength. So we could conclude that HNT act as a reinforcing agent and could improve the PAPPC stiffness without sacrificing a significant decrease in tensile strain. Next is the flexural test. Okay, figure 4 shows the flexural strength and modulus of 7030 PAPPC with different content of HNT. So the flexural modulus of 7030 PAPPC blend decreased from 1,698 to 1,460 when 2% of HNT were added. However, the flexural modulus will increase and keep increasing when incorporated with 4% of HNT. The HNT, when the HNT increased to 4%, the value of the flexural modulus increased to 1,762 MPa, which is much higher than without the incorporation of HNTs. When we compare to the need per A, we could see that the flexural strength and the flexural modulus were increased compared to the 70-30 PAPPC without the addition of HNT. Figure 4 shows the impact strength of 70-30 PAPPC with different content of HNT. Okay, with the addition of 2 to 4% of HNT, we could see that there is no significant increment or improvement in terms of its impact strength, where the impact strength of the PA-PPC HNT nanocomposite varied from 8.61 to 8.76 kJ per M2, and then further increase of a filler HNT to 6% resulted in a slight decrease of impact strength. Okay, this might be due to the aggregation of HNT in PLA-PPC matrix. However, when we compare to the NIP-PLA, the impact strength is significantly improved. Okay, next is the thermal properties. So figure 5 shows the DSC thermogram of PA-PPC HNT nanocomposite. Okay, here we could see that the NIP-PLA were recorded, the TG of the NIP-PLA were recorded at 48 degrees C. Okay, there were two TGs for PA-PPC blends, which shows that the blend is partially or immiscible blends. Okay, when the HNT increased to 6%, the TG of PPC and TG of PA tends to move towards each other, which can be concluded that the addition of HNT had improved the miscibility of the blends. Okay. Meanwhile, the TC HNT resulted in an apparent shift of TC value from 103 degrees C to 117 degrees C. Therefore, it can be concluded that the increase of HNT has restricted the blend's molecular entanglement, thus reducing the 70-30 PAPPC flexibility. And then the double melting temperature refers to the melt recrystallization mechanism of PA during the second heating cycle. So during the second heating, the less perfect crystal of PA have gained enough time to melt and form more perfect crystal. Later, it will melt again to create a higher melting temperature. So here we could see that the amount of HNT does not significantly influence the TM of the nanocomposite. So as a conclusion, for the mechanical test, we could say that the incorporation of HNT could improve the tensile, impact, and flexural strength of the APPC blends. The blend's stiffness is remarkably improved, as we could see that previously the Young modulus of the nanocomposite increased with an increase of HNT. And although the elongation of the 70-30 APPC is decreased with the addition of HNT, but the value is still much higher compared to the elongation of the NIP-PLA alone. And for the thermal properties show that the incorporation of HNT does not significantly influence the TG, TC, and TM of the nanocomposite. The addition of HNT improved the miscibility of the PLA-PPC since both TG has shifted towards each other as the amount of HNT increased. And finally, the presence of HNT has restricted the flexibility of the PLA-PPC HNT nanocomposite due to its rigid structure, which has limited the change mobility of 70-30 PAPPC. This decreasing flexibility is related to the gradual decrease of the crystallinity. So that's all from me. Thank you.
Okay, thank you, Ms. Intan. So now I open the floor for Q&A sessions. Anyone have a question about Ms. Intan's studies?
Can I ask questions?
Okay, please.
Thank you, Ms. Intan, for the interesting study. Based on your maybe literature review or understanding, how can actually the HNT improve or change the physicochemical properties of your material?
How can actually, okay. It has a tubular, HNT has a tubular nanostructure. So when we blend, the material actually the matrix will actually mix together, and then it will improve the mechanical properties. And we support the answer by doing some testing on the thermal properties. And we, as I previously,
Is it fill the pores inside your material? Is it
yes,
all
yes.
those? And then what is the bonding between your HNT and also the surface of your material? I'm not so sure anything in the material. Is there any bonding that causing the effect, or is just fill the space or
Uh,
the empty space
it
inside your
feels
material?
the, as I understand, it feels the blend itself.
Mm.
Of course, further experiment will be conducted, such as the by using the morphology observation and so on.
Okay, thank you, Miss
But
Intan.
currently, we just test with the uh, mechanical properties and also the thermal property test. But further study will be added to investigate, like as I mentioned, morphology observation.
Mm, thank you.
Thank you, Dr. Rika. So I do agree with Dr. Rika. So a detailed study should be carried out in terms of the distributions of your filler or particles, as well as the interactions between the filler. And if you claim that there is the filling or some, you also need to study if Dr. Rika say it's about filling the porous structure. So you need to know about the density of the material as well. Okay. So, is there any question from the floor, Dr. Malinda or any Miss Nur Sayyada? Is there any question from you guys? Afri, from yourself, is there any question for the speaker? If not, I proceed with my question. Okay, so Miss Intan, you claim that one of the advantage of this combination is on the biodegradable properties and biocompatibility properties as well, eco-friendly as shown in the slide. So can you prove it?
Biodegradability and biocompatibility. Oh, currently I have conducted the biodegradability test on PAPPC, uh, and it's still in it's still in progress. But previously I have conducted the biodegradability test on PLA PPC uh, during my studies, master studies, and we could see that there is a decrease of the percentage of the mass percentage of the PAPPC. So
Okay, so my next concerns is about the reinforcement effect that you highlight in your composite.
mhm.
So, can you, from your literature or your reading, I know because you mentioned that it's an early stage of your research, but from your understanding, how the HNT act as the reinforcement agent for the system?
Okay. Um, do you mean the
Yes, because the improvement of strength is quite significant for this study. So, and you claim that it because of the reinforcement effect. So, can you explain in details how the mechanism of reinforcement effect here?
oh, okay, wait, I can show you some. I think I can show some.
It's okay, Miss Intan. So you just bring this note back and then discuss
Okay. So I
to
should
do it.
mention in my project how does this
Yeah, because this is the main reasons
oh
of
okay.
the mechanical properties.
Right.
Okay, so thank you very much, Ms. Intan, for the good presentations and the Q&A session as well. So without further ado, so we will move to the next presenter, Mr. Azam Muhammad Adnan. He's from Nanotechnology and Catalysis Center, UM, and he will talk about the photocatalyst system for for the environmental applications. So, Ms. Intan, you can stop sharing the slide, And now I invite Azam to share his slide. Mr. Azam, now the floor is yours.
Bismillahirrahmanirrahim. Okay, Assalamualaikum and very good morning to the member of the floor. Today, I would like to talk about the effect of concentrations of manganese dioxide on the formations of manganese oxide, zinc oxide, thin film, and its degradations towards the malachite green. So these presentations we will cover into the introductions, problem statement, objective, methodology, result and discussions, conclusions, and finally is the acknowledgement. So as introductions, nowadays the developments of our country or in the world more to the sophisticated building involve the tall glass fronted building are being constructed for both. So in this case, organic dirt and bacteria pose health risk to residents in the building either from the indoor or outdoor environments. So besides, window glass cleaning require massive labor and cost of vast sum of money. So that it would be important to develop energy efficient window coating with the self-cleaning features. So in here, photocatalytic self-cleaning technology considered as the cost-effective approach due to the outstanding ability photocatalytic degradations of organic dirt and photo-induced hydrophilicity. So the photocatalysis give the advantage of degrading pollutants using only oxygens and oxidant low cost, resulting in safe and environment-friendly products. So the problem statements of this project is there are increasing number of tall glass front building for both resident or commercial purpose built. So organic dirt and bacteria pose health risk. So how we can solve this problem? So in here, design a stable and environment-friendly photocatalytic self-cleaning system for smart glass coating. Other than that, also existing material has a critical problem, inhibit the cost effectiveness and or reliability of smart glass. So that in here we choose manganese dioxide has a narrow band gap energy 1 to 2 EV that poses high possibility to be driven in visible light regions or conditions. So why we choose why we use manganese oxide? Because the low toxicity, strong oxidants, inert and chemical stability, abundant and cost effective. And why zinc? Because low cost, got good oxidizing power and biological chemical inert. The both of the advantage will be beneficial in making the strong or good potential photocatalyst that can be used in these applications. So what is the benefits of these products? So for environment, it will give the natural cooling effect, energy saving, environmental friendly. For the nations, it involves the building. So the reduced average building energy index, BEI in Malaysia. For society, when we develop these things, so society smart living lifestyle, high comfort level, reduced energy usage, and a conditioning that's very benefit for us. Also, for economy, the less consumptions overall creating job and boosting the local economics. So the objective of this project is to design a stable, environment-friendly photocatalytic self-cleaning system for smart glass coating. and study effect the manganese oxide concentrations on the formations of hybrid system via chemical bulk depositions, and to analyze the photocatalytic self-cleaning performance manganese zinc oxide system thin film. So in here, we produce the coating, the formations of manganese oxide using the chemical bulk depositions. So why we use the chemical bulk deposition? Because it's very low cost and simple instrumentations. So in here, we have a two-step, a single-stage CBD and two-stage CBD. So the initial stage deposition solution was prepared by dissolving calcium permanganate in distilled water and using the ethanol as a reducing agent. So then the solutions was transferred to the glass vial and kept immediately into the water bath for 20 minutes at 85 degrees C. So that in here, there are two types, inoculation and growth. For, as we can see in the figure, the difference between the single stage CBD and two stage CBD is the process. In the single stage CBD, we have nucleation and growth. With this is together, but in this two-stage CBD process, we separately the nucleations and growth to make it the more cover on the coating system. So in this, the growth mechanism, when we use reducing agent ethanol here, we got the product manganese dioxide here. So as an example, you can see at the right is the example of the coating we have done in this project. So the result for morphology of the study of the manganese oxide, it can be seen the manganese oxide thin film morphology initially grow as a flakes, but gradually becomes spherical over the deposition time, which is displayed in 20 minutes of two-stage depositions. So after that, we conclude that the two-stage CBD is better than initial stage meaning one step. So that we continue with the two-stage CBD process. In here, as we can see the result, the morphology of the top view surfaces, the A is initial manganese oxide, which is we just using the first step, and then B is the morphology, the structure of the two stages manganese dioxide. But when we combine with the zinc, the slight reductions of the particles, resulting highly porous structure compared to the surface morphology of initial stage and for first step and second step of manganese dioxide. So after we combine that, the self-cleaning mechanism, as we know, we use the light source to make it from harmful to harmless, just using the simple process of the photocatalytic process. So in the photocatalytic activity here, the zinc, the manganese system, which is 12% display the better photodegradation efficiency with 6.45% in 19 minutes compared to zinc with 10% with 5.33% of degradations. It also worth to mention here, all two stages of CBD in thin film exhibits a slight improvement in Mg, molecular grind degradations. So the main reasons due to the particle agglomerations become more noticeable for the two stage of CBD and a longer deposition time, which can be accounted by lowering the concentrations of two-stage CBD. The thermal insulations, because we try to use this one in the smart window applications, the thermal insulations analysis is the main one of the main factor or main key in these applications. So what we found that the zinc with 12% of weight ratio is show the lowest interior temperature, reaching its constant temperature of 35.9 degrees C at 65 minutes. Meanwhile, for zinc with 10 and 8% weight ratio, both reach its constant temperature is 36 and 36.1 respectively. So this result indicate the 12% zinc ratio in nanocomposite film exhibit better overall thermal insulation performance. So as a conclusion, magnetic system thin film was successfully deposited by using the two-stage CBD, and zinc with weight ratios of 12% in manganese dioxide zinc oxide system demonstrated the best insulation performance as only reached 35.9 degrees C for 65 minutes. However, all the thin films indicate low photocatalytic activities with 6.45 degrees degradation efficiency of 10 milligram per liter mg within 90 minutes in visible regions. So the result indicate that the manganese dioxide zinc thin film portray a promising candidate for energy saving and self-cleaning window coating. So this project is financially supported by Selangor State Research Grant and UMRU grant. So thank you.
Okay, thank you, Mr. Azam, for the presentation on application of photocatalyst for the smart windows. Now I open the floor for Q&A sessions. Anyone have any questions, or you want to know more details from Mr. Azam? So you are most welcome to ask. Any question from the floor? Dr. Yusliza, any question from you? Or Mr. Tan? Ms. Nasiada, any question from you guys?
Hello everyone. I'm Dr. Tan here.
Mm-hmm.
Okay. I wish to ask Mr. Muhammad Azam,
Okay.
because I'm entering the middle of your presentations. Do you conduct a UV analysis on your sample in your
Pardon?
work? You
Pardon?
conduct UV analysis?
Yes, yes.
All right. So would you mind go to your slide? Can I take a look again? Would you mind share your screen? Just
wait.
Oh, sure.
Okay. Okay.
You can go for UVV's result.
Okay. This is UVV's result. Because after that we have to analysis that, then we come up with this one.
Okay. All right. Can you explain more about the reason when you say the particle agglomeration become more noticeable for the two stage of CBD? May I know what's the factor cause these particle agglomerations?
Okay, in the particle agglomerations, because can be affected because of the time and the temperature, in here, because we have the concentrations, because in order to synthesize or to make it the thin films, the major the main parameter is at the time we have to control it. But then because the concentration was added in the solutions, and then the time within the 10 minutes, something like that, because we tend make it the particle agglomerate, because the time we dip into the solutions. So that's why we have to control that to make it the sample become more surface, more porosity, more porous. So in here, the porosity is the key factor here, and in order to get the better photocatalytic activities. So, but then, as I mentioned here, the result of the photocatalytic activity is very low. But then we have to study how we can use to increase the photocatalytic activities. In here, based on this, in this study, we are now in track to increase the percentage of zincs and the time of the CBD depositions, because as we know, the agglomeration means the main factor in to make it better photocatalytic activities.
All right. Thank you. Okay, I understand. All right, thank
I
you.
have questions. Yeah.
Okay, yes, please. Dr.
Thank you, Mr. Azam, for your presentation. But actually, you have a good data on how it can, degrade this malachite green. However, I also heard that you mentioned it is for smart window, right?
Yeah.
So, how can you relate your punya testing to the degradations of dye to the applications of smart window? Because
Okay.
I'm thinking that if you are talking about smart window, you probably would like to have your film to degrade the indoor air pollutants, right?
Yeah.
Or it is different because smart window and then the testing is on solution. So can you do some relation on this, or maybe you would like to do further study on the indoor air pollutants?
Basically, because I understand you, Dr. Rika. Thanks for the question. Actually, basically, we are trying that because to prove that this the main thin film what we have developed have the potential to be used as self-cleaning. So why we test using the what we call malachite green, because the process is the photocatalysis. Photocatalysis, as we know, we can use anything because it depends on the application what we need to do. So in this particular thing, we have to make it the relations that our catalyst is possible to do the self-cleaning. So then after this, we are going to do the further study as you mentioned. We are going to do the test for the further study for the indoor test.
Just to suggest something, because actually it's not easy to just compare with solution and also air tau. For example, if you are using like the common indoor air pollutants such as formaldehyde, usually you will have secondary pollutants, secondary byproducts, such as you cannot complete the catalytic reaction. So what happens, you will have CO. Deposited on the membrane, or CO released to the environment. So because at the end you would like to have CO2 and water. For example, you would like to do the oxidative reaction to the formaldehyde in order to get CO2 and water. But most of the catalysts, it's very difficult to find the best catalyst to do the complete degradation. In some cases, you will have byproduct, which is toxic to the environment. So that is why I believe if you would like to go for the smart windows, so try to have related experiment or test model air pollutant lah, as compared to using malachite green. That can help you to to link the performance study to your potential application.
Okay, thanks, doctor, for the suggestions. I will consider that
Okay.
for further study. Okay.
Alright.
Okay. Thank you, Dr. Rita, for the input. Any more question from the audience? If no, so
Dr.
can I proceed with my own question?
Dr. Laili, I have a
Oh,
question.
okay, Dr. Malinda, yes, please.
Yes.
All right. Okay. Thank you, Muhammad Azam, for your nice presentation. I'm second with Dr. Rika as well. Since you are saying that the photocatalysis is for self-cleaning window, so I'm wonder, is there any study for you that you have done to check on the sustainability? For example, like reproducibility, that have you done before?
Reproducibility. Okay.
Reproducibility.
For the self-cleaning itself, we already done for 3 cycles. 3 cycle, and the result is reduced to 2% only. But then, as Dr. Rika, I also mentioned or addressed in the study, the result, uh, we still have a low photocatalytic activity. So that in this sense, so we need to do something to improve that photocatalytic activities for the catalyst. But then the reproducibility, after 4 cycle, it reduced to 5% to 10%.
Okay, thank you, Muhammad Azam.
Okay, thank you, Dr. Malinda. So, Mr. Azam, my question for me, how you can see that this product can be commercialized?
Oh, that's a very tough question. But then, with support of the government, I think, or further study, we can use to get the better and convincing result. We can do some collaborations with other industry to propose this product, because as I mentioned in the slide introductions, is related to the building, because we now are a developing country, so architecture using many sophisticated design that use the glass. So when we propose something like this, I think is will beneficial to industry and our country also. That's all.
Okay, thank you, Mr. Azam, for your presentation. So before we proceed for the next presenter, so Dr. Tan is here. So we would like to ask the cooperation for all the participants here, for all the audience here, to switch on your camera for our photo sessions. Okay,
Just a
switch on
minute,
your camera
Doctor.
and yeah, and give a big smile.
Prof. Dr.
Yes.
Yusliza, can you please join?
Yeah, Dr. Yusliza, anyone here? Yeah, Intan here. Nur Syahida here. Okay. Dr. Malinda here. Dr. Rika here. Okay. So, Dr. Tan, whenever you are ready, we just
Dr.
waiting.
Yusliza,
Okay.
Dr.
can you please
Yusliza?
All
come to
right.
the screen?
Mm.
Dr. Yusliza is here, but not on the screen.
Oh, Dr.
Can you join?
Yusliza, can you please switch on your camera? Oh, okay. Dr. Tan,
All right. Yeah.
okay.
Okay.
Okay, smile.
1, 2, 3, smile.
Hmm.
Okay, one more shot, one more shot. One more, 1, 2, 3, smile. Okay,
Okay,
all right.
that's okay, right? Okay, thank you everyone. Okay, so we may proceed for the next presenter, Miss Nur Saida. So Miss Nur Saida will talk about the graphene composite, the ternary hybrid system of the graphene-based composite. Miss Nur Saida, now floor is yours. Just a gentle reminder that you only have 50 minutes for the presentations and followed by 2 minutes for Q&A. Okay, Miss Nur Saida, you may share your slide now.
All right.
Can you all see now? Hello, can you all see my slide?
Yes, but in the PowerPoint format. You change to the slide presentation?
Prof, just an interruption. Prof, Dr. Yusliza has joined. Do we go for the photo again?
I'm okay. Did we behind? Okay, so okay. Everyone, switch on again your camera and look do the Photoshop thing. And no, Saida, maybe you can stop sharing your slide for a while.
Okay, wait for a while.
Okay.
Sorry, Dr. Laili, I just lost my connection.
It's okay. So, okay. So,
Okay, I will take the photo. All right.
Okay.
All right. Okay, 1, 2, 3. Okay, one more. All right. All right. Okay, one more. 1, 2, 3. Smile. Okay. All right.
Thank you, everyone. So, Miss, Miss Nosaida, you may continue the presentation.
All right, wait there.
Okay.
Okay, thank you, everyone. Assalamualaikum and very good morning. My name is Nur Saida Damasinho, PhD student in University of Malaya, supervised by Professor Dr. Muhammad Rafi'i Johan and Associate Professor Dr. Hairul. My talk will focus on the recent advances on ternary nanocomposite for water treatment. It is basically a literature study on ternary nanocomposite for water treatment application. Okay, I will divide my talk into 4 parts. Part 1, background, in which I will briefly talk about the current global needs for clean water and how nanotechnology and particularly ternary nanocomposite can play important roles. In part 2, I will be talking about the current trend, sharing with you some data finding in the literature on the works related to ternary nanocomposite for treatment. 2 synthesis methods typically used for ternary will be briefly explained in part 3. And finally, some challenges for future works are identified and briefly discussed in part 4. Allow me to start by looking at the general background of the work. According to the recent report by UN Water 2021, the world is continually facing global water issue.
Excuse me, Ms. Nusaida, can you please
Yes?
change to the reading view or the presentation view? Now
I already pressed the presentation view actually.
Because actually probably you have 2 windows, one for your reading, one for your presentation if you go for presentation view, so we cannot see the movement of your slide. We just see your slide in your editing version. Maybe you can change to reading view, as mentioned by the IT committee. Reading view also helpful.
So I stop screen first.
Screen, but try to change to reading view or present in individual window.
Yeah.
Because when you move your slide, we cannot see the movement of the slide.
Oh, okay. I try use this one.
Yes.
Oh, okay.
Okay.
Yeah, it's good now.
Oh, sorry. Wait. Sorry, yeah.
Thank you, Dr. Lika, for your great explanation. You're absolutely correct.
Okay, now you all can see?
Can you?
Now you can see the movement of my slide?
Yeah, can. Now can.
Okay, Okay, I start from here. Okay, allow me to start by looking at the general background of the work. According to the recent report by UN Water 2021, the world is continuously facing global water issue. In fact, it was reported that more than 2 billion people are lack of safely managed drinking water and 44% of household wastewater is not safely treated. To address this global issue, a number of efforts are in place. In fact, there exist many strategies that have been developed for water treatment, including coagulation, sedimentation, filtration, decontamination, disinfection, and desalination. In these strategies, nanotechnology appear to be one of the most important research areas. In fact, nanoscale particle and structure possess interesting chemical, mechanical, and physical properties that are suitable for water treatment application. Among available nanomaterial, ternary nanocomposite have gained an increasing interest among researchers to be used for water treatment application. Ternary nanocomposite are nanostructures that combine three different nanocomponents which could be either metal-based, carbon-based, or polymer-based. Ternary nanocomposites are interesting as they display excellent properties and activity due to the synergistically improved physicochemical characteristics of the nanocomposite. While some progress have been made on ternary nanocomposites, it appears that research in this area is still insufficient despite the huge potential of multis to look at the current situation and trend on the work related to ternary nanocomposite with a focus on water treatment application, which will be discussed on the next part of my talk. Okay. In the span of 10 years from 2012 until 2021, the Web of Science has recorded 67 publications related to ternary nanocomposite of water treatment. The detailed cumulative number of publications is presented in the right bar chart. As you can see in this chart, not only the number of publications increased, but it also was to note that publication increased at a much faster rate, especially in the last 5 years. This data show that there is a growing interest in the scientific community in exploring the potential of ternary nanocomposite for water treatment. Next, let's have a look at the detailed breakdown of these 67 publications. In total, there are 91 institutions that are involved in these 67 publications. As you can see in the left chart, huge majority of them are institutions from Asia, 77 out of 99 or 85%. The remaining 15 are shared by the rest of the continent, 4% from Europe, 3% from America, 6% from Australia, and 2% from Africa. If we look at the 77 Asia institutions, 4 countries are leading: China with 35 institutions, India and Iran with 30 institutions, and South Korea with 6 institutions. As mentioned earlier, ternary nanocomposites are nanostructures that combine 3 different nanocomposites or compounds. This nanocomponent could be either metal-based, carbon-based, or polymer-based. Different types of metal or metal oxide typically used in ternary nanocomposites. For example, silver, zirconium, and copper are widely used. While for metal oxides, the typical use are iron oxide, titanium oxide, and zinc oxide. Iron oxide possess magnetic properties that could alter magnetic pollutant, while titanium oxide and zinc oxide are semiconductor photocatalysts to degrade the dye. Carbon-based material are another common component used in ternary nanocomposites. They are well known for their capability to remove impurities and contaminants in the water. Carbon are typically used either in the form of graphene, graphene oxide, or reduced graphene oxide. In a number of studies, polymers are also found as a compound in ternary nanocomposites. For instance, PPY were used in the work of zinc and co-workers to their high charge surface. Polyacylic acid was used in the work in Hosini and co-worker, while polyosometalates was used in the work of Zan and co-worker as adsorbent for removing inorganic and organic contaminant. In this part, let's have a look at the typical synthesis method for ternary nanocomposite. In general, there are two typical synthesis methods used in produce ternary nanocomposite. That is hydrothermal synthesis and also solvothermal synthesis. Hydrothermal synthesis is a synthesis through chemical reaction in aqueous solution. That is to say, using water as a solvent. While in solvothermal synthesis, chemical reactions are conducted in non-aqueous solution, or in other words, using water as a solvent. Hydrothermal synthesis is typically conducted above water boiling point, while solvothermal synthesis performed at relatively high temperature. Okay, both hydrothermal and solvothermal synthesis method use reactor. Here in table 1, the most commonly used reactor are provided along with their corresponding temperature and pressure. For the situation where high temperature and pressure are required, the commonly used reactor are cone closure, piston cylinder, and opposite diamond anvil. While for solvothermal synthesis, where the reaction are conducting non-aqueous solution, the commonly used solvent are methanol, ethanol, toluene, and ethanol amine. In addition to what have been presented in the previous slides, table 5 provide information on typically ternary metal oxides are achieved using hydrothermal and solvothermal synthesis method. As can be seen in this table, depending on the metal oxide used, the obtained morphology can be either nanoparticles, nanowire, cubic nanoparticle, or polyhedron particle. As highlighted in the previous slide, except for the type of solvent used, hydrothermal and solvothermal are basically a similar synthesis process. For the sake of example, here is the illustration of hydrothermal synthesis conducted by Kumar and co-workers in 2020. The team synthesized single-phase PEG 400 coated for a duration of 16 hours. The process can be summarized in the following. The precursor salt, iron
Internet connection.
Is it the presenter lost
Yeah, she's
a connection, right?
reloading.
So for the time being, maybe if you have
Yeah,
any
stop.
questions, so you can prepare the questions. Oh, once she joins, so she can directly go for the Q&A session.
All right.
Okay. Yes.
Miss Nurhida, you cannot refresh because she's here but cannot come to the screen.
Uh, Dr. Tan and everyone here, can I ask opinion? So can we just proceed with? Oh no, she had text. Okay.
Sorry,
John,
I have a problem with my internet connection.
Okay. So Noseda, if you don't mind, if we can just go
You can
directly to
hear me
Q&A
now?
session. Yes, yes, we can hear you. So if you don't mind, we can go for the Q&A
Hello?
session. Hello? Hello?
Hello, Miss Afrin. Can you hear me?
Yeah, yes, we can hear
Yes,
you,
yeah, we
but
can hear you.
the chair session was asking you that whether we should go, we can go for Q&A directly, or you want to present again.
Can we
Oh,
go
okay,
for the
okay, can
Q&A?
continue.
Okay, so because we are
Sorry,
behind the
because
time.
my internet connection is
No
problem.
problem, no
Okay,
problem.
it's okay. Okay, so
So
anyone
I
have
stop.
question for
It's okay.
Noseda?
yeah,
Anyone?
I think let her to proceed. I think she has a little bit slide, right? If I'm not wrong, remaining few slide, right?
Yeah.
All right, okay, you can carry on. You can carry on.
Okay, thank you.
According to timer, as I have stopped, we have 3 minutes 30 seconds. Okay.
All right.
Okay.
Sorry, my connection is very poor. I cannot share the screen.
So that's why
Oh.
if possible, we just go
I
directly
don't know
for
why.
Q&A. So
Yeah,
yeah.
Can she try to off your video to reduce the need
All
of your
right.
video and try to share? Is it possible?
Okay. Because when I click, I still got the cross button on the screen. I click and cannot press the button.
What I would like to know as evaluator is at least probably you have study that you would like to share. You can just mention about it probably. Is it possible without having any slide? Yeah.
No need to use the slide, yeah?
Yeah,
Yes, yes.
if it is difficult, you just mention what you have done related to the study and what
Okay.
is the results and discussion.
Okay, and then I go to the final part. Okay, in this part, I would like to highlight a few challenges of work that remain to be done. From many possible avenues, it seems that green nanotechnology has become an important and integral part of future technology. It is clear that any new technology development should not create or lead to new environmental issues. Along this line, a number of opportunities for future work are available as follows. First is the green synthesis. Green synthesis which employ organisms such as plant, bacteria or fungi for the synthesis of nanomaterial become a popular method of synthesis. Some work have been done and advances have been made. However, in our context of ternary nanocomposite, synthesis or reaction parameter optimization for specific ternary nanocomposites, especially if mass production is needed. The next thing to look at is the material itself. Some sustainable and environmental friendly material for water treatment application have to be explored further. For instance, carbon-based materials such as graphene oxide, reduced graphene oxide, carbon nanotube or activated carbon. Natural resources and materials such as cellulose has gained considerable interest lately. Also, new combination of ternary nanocomposite can be explored. Another research area worth exploring is the toxicity issues of nanomaterial. In fact, there is a growing awareness on the potential risk of dealing with nanoparticle. That's the toxicity of long-term exposure of nanoparticle to human beings should be truly assessed. Finally, the issue of mass production and cost analysis of nanotechnology for commercial purpose need to be further studied. In fact, at the moment, no comprehensive data is available in the literature on the cost-benefit analysis of ternary nanocomposite of water treatment application. With that, I came to the end of my presentation and thank you for your kind attention. Sorry, because I have a problem with the internet connection.
Okay. Okay, thank you, Ms. Nur Saida, for the presentation. Okay, so now I open the floor for the Q&A.
Ms. Saida, thank you for the presentation. Okay, actually it's a good presentation. You can deliver it well. It's just that you have some issues related to the connection. I would like to know because you have ternary system, kan? And it means that you add more materials, thus you will add cost. But of course, if you have ternary system, the performance or the properties will be better. So how can you comment if you look into the performance and the cost? Is it feasible to have this kind of ternary system? Do you have any comment or reading on this? Maybe how many fold performance can be achieved comparing to the increase of the cost of that material? Internet connection loss.
Miss Nasiada, are you with us?
Maybe I need to type. All right.
Okay, yeah. Maybe you can try. And
So, Dr. Rita, you are typing the question?
Yeah, I'm typing the question, but others can also ask if you would like to. Okay.
so, Miss Nusaida, we have 3 questions here. Can you hear us now? I think she can. Can you say something?
I think she's not on the line.
She's not in the line. Oh, okay.
Yeah.
We give her 2 minutes, or in case maybe 2 or 3 minutes.
Is it possible we can proceed with the Q&A for Norsaida? Maybe we can let the invited speaker to proceed first.
Yes.
Is it possible?
Yeah, yes. Okay. So, Dr. Malinda, are you here?
Yes, I'm here. I can hear
So,
you.
okay. So, while waiting for Ms. Nosaida, so we would like to invite our invited speaker, Dr. Malinda from University Malaya. So, she will talk on the graphene-based composite for the wastewater treatment. So, without any further ado, I would like to invite Dr. Malinda to the floor. Thank you.
Okay, let's me go to my slide first.
Sorry, I think I wrongly mentioned your title.
Yes.
It's about the graphene rubber composite. Okay, sorry. Okay.
It's okay. Okay, I will try to share as a window. All right. Right, share. But first of all, I would like to apologize if there is any internet disturbance, or maybe I can just switch off my camera to allow my presentation to on smoothly. Can see my slide moving?
Yes.
Okay, great. All right. Okay. So first of all, I would like to thank chairperson today, Dr. Laili, and also respective presenter and also audience. So Assalamualaikum and good morning, everyone. So first of all, I would like to thank conference organizer, Nanocat, and also the ICTP for having me here as a presenter, one of the presenter for this session today. So today I will share my slide on the presentation on the title of electrical properties based on low content of a graphene filler in natural rubber graphene composite. So without further ado, let me share my overview of presentation today. I will go the brief introductions on the research challenge and the motivations, research background, including graphene and also natural rubber, respectively. And we will go on the methodology and also materials and implementations. And also we will look at the result and also analysis. Last is the conclusion, acknowledgements, and also the references. Okay, nowadays, growth on the development of flexible pressure sensor, flexible electronic devices has significantly increased due to the high demands on healthcare activity, such as demands for IoT, Internet of Things, robotic, healthcare, communication, transport, and many more. So generally, it is not compatible with the traditional silicon metal-based electronic. So because of that, there are a few issues that need to consider towards the integrations and flexible electronic platforms, that is including the demand for a minimum cost and higher that has the higher in transparency and also higher in flexibility, low in weight, and have the optimal electronic control. And lastly, it should have the simple integration processes. So the growth of flexible electronic has been predicted by a global flexible market industry trend and forecast to 2027. It says that the flexible electronic market will be growth at a rate of 11.25% in the forecast period of 2020 to 2027. And the growth have been divided. This market has been divided into three market segmentation, which is by applications, by verticals, and also by the geographical segments. So I would like to draw your attentions on the application and vertical segment, where it shows high demands on flexible electronics such as display, battery, sensor, memory, and many more. And on the segment of verticals, the target market are focusing on electronic consumer, automotive, healthcare, and also etc. So as a motivation for this statistic, in light to this development factor, researcher and industries are now focusing on the fabrications of nanoparticle polymer composite in order to improve the functionality and also stretchability functionality of stretchability properties, and also to improve the interfacial adhesions between the polymer matrix and the nanoparticle or nanofiller that being used in this So therefore, considering these interesting mechanical properties, electrical properties of the graphene, we had considered in our study to use the graphene as suitable candidate for a material into polymer matrices, which is a natural rubber. So later we study the mechanical effect and the conductivity has been carried out, and I will share with you later on the outcomes. Next slide. Okay. So before we talk about the natural rubber-based graphene composite, let's talk about the graphene. So what is graphene? Graphene is a 2D layer or monolayer of carbon atom that tightly bound in a hexagonal lattice structure. And it also can be referred as a basic structure of allotrope, including graphite. So as shown in the figure, in the right-hand side figure here, if we take out a single layer of a graphite sheet, we actually can produce a graphene. So this graphene is nothing else than just a single layer of graphite. So let me talk about the brief introductions about graphite. So graphite is a pure crystallite carbon that was discovered in 1564 at the Situ, England. And at the first time, it was used to mark their shape. And later on, in 17th centuries, they have sewn the graphite sheets into a sheets and cut into a square rod, and then insert into the handcuff wooden holder to create a pencil. This is the 7th century pencil, and this is our modern sample. There is a lot of differences you can see. And so now let's look at on discovery of the graphene from graphite. So graphite was first isolated in 2004 by two Russian scientists, which is Professor Andrei Geim and his student at that moment, Professor Konstantin Novoselov. And by using the exfoliation method of the graphite, using a Scotch tape, as I mentioned previous in our keynote speaker, Prof. Panchanan Pramani has also explained this method. And in 2010, the Nobel Prize in Physics was awarded to these two scientists for that discovery. Okay, let's look at on the structure of the graphene. So graphene have a few dimensions. It can be a 0 dimension that can be formed from the wrap of a graphene to form the fullerenes, and also can be rolled into one dimension nanotube, for example, to form carbon tubes. And as I mentioned earlier, if we stack up a graphene, we can form a 3D three dimensions of graphite structure. Okay, so why researchers were very much interested on the graphene based material? This is because of their amazing properties. For the first one, graphene is known as the thinnest known material with only one atom thick. It's about 0.344 nanometer, and it will take about 3 million stack of graphene sheets in order to equal to the width of the pencil tips. And despite of being the lightest material, it also the strongest material ever measured, which is 200 times stronger than a steel. And according to the Wikipedia resources, it's given an idea that it requires an elephant that balance on the on a pencil in order to break the sheets of graphene with the thickness of clinched films. So furthermore, it also graphene also only not allow anything to pass through it except the water molecule. This is because the water molecule has the dimensions about 0.27 nanometer, and therefore it has a huge potential in turning water into vast drinking supply, as it is possible to remove salt from the seawater. So last but not least, graphene also can conduct electricity and heat better than other materials. Okay, now let's look at on how graphene can be synthesized from graphite. So there is two approaches that can be used, which is the bottom up and also top down approach. And there are six significant methods that are commonly used. That is including the epithelial growth, chemical vapor deposition, chemical oxidation, chemical reductions of the graphene oxide, and also electrochemical treatment that can be employed to prepare these two approaches in order to produce graphenes. So how can a unique quality of graphene will help us in the world that we live in? So there are many potential of graphene, including it contribute in the manufacturing of ultra speed transistor, sensor, supercapacitor, battery, and etc. So Hevia brasiliensis is the scientific name for rubber tree. So meanwhile, natural rubber consists almost exclusively of cis-1,4 polyisoprene polymer, which can be found in the latex form, that can be obtained by slashing the bark of the rubber tree in order to reach the latex vessel. So it can appear in latex can be appear in three significant form, which is a milky fluid, and it has an odor and also sticky properties. Okay, here is I share with you the properties of natural rubber. So there is amazing properties of natural rubber is that it is eco-friendly. It has the high toughness, sensitive towards the temperature, also biodegradable, and it has very sustainable properties that can act as a renewable resources, which can be extracted within short time, as it have the first harvest period is about 7 to 10 years, and also can sustain for harvesting period about 20 to 30 years. And there is other properties of natural rubber such as elastic and also impermeability. I hope everyone is still bear with me.
Yes, we are
Yeah,
here.
okay. All right, okay. All right, so all right, thank you. So graphene is actually a well-known material that have been used as a filler in rubber reinforcement in the past few years. This is because of the excellent properties. So I will share with you there is three possible route to prepare graphene polymer based composite. So the first one is in situ polymerization. In situ polymerization, intercalates of graphene oxide with a hydrophilic polymer or polymer monomer, and then this intercalation polymerization will be isolated to produce a single graphene layer sheet. And for example, in situ reduction and polymerization of PVDF graphene oxide film. So the second step, the second route is the solution mixing. It's also known as a solution casting or solution process. And this approach can produce a natural nanocomposite from a variety of polymer in highly scalable manner. And this approach is actually simple and straightforward approach. However, it has not been yet demonstrated to produce a single layer of graphene sheet without using of stabilizer or any surfactant. And the last possible route to produce graphene polymer based composite is by melt blending. This process has been, if I'm not mistaken, Miss Intan is just now sharing about this method. And this actually need of two or more constituents materials within a given phase. So this melt compounding is actually utilized both shear force, high shear force, and also high temperature melting in order to blend filler and matrix in a matrix material. So it doesn't require a common solvent for graphene filler and also polymer matrix. So for example, as mentioned in the first presenter is mentioned about the polylactic and also the composition with some other materials. And other than that, there is another example is PET, and PET reduced graphene composite also can be prepared by using this melt compounding. So what does this graphene enhanced composite offer? So polymer graphene composite can offer a good electrical conductivity, better thermal management, because it can increase the glass transition temperature due to the strong interaction between a polymer and the graphene. And it also can offer the UV protections in the longer wear, and it also having the anti-static properties, and also can reduce the weight because of the properties, lightness properties of the graphenes. So other than that, it also can improve the robust robustness, and also the mechanical reinforcements, flexibility, barrier properties, and also can enable to be self-monitoring, for example, sensor application. So in our previous work, we have reported the synergetic effect of graphene as a filler in enhancements, mechanical and also conductivity properties of the graphene composite. So here we are using a liquid exfoliation technique was obtained to obtain the graphene dispersions in the dispersed in the dispersed in the NMP solution. And the mild sonication and simple mixing technique were used to prepare the composite. So via the dry cast for overnight at the temperature of 100, we can obtain natural rubber graphene composites after the removal of water molecules. So in this study, the compositions of the filler will vary from 0 to 2 volume percent. So what do we expect from this material? So the advantages is that it can build we hope that it can produce form built-in piezo material, and also it also can be it also produced by a simple manufacturing process, which is by a solution mixing process, and it shows a better conductivity, of course, flexibility, and also a light in weight and highly sensitive, and many more. So let me share with you, there is a few characterizations that has been carried out. So in order to confirm the compositions of the graphene, we carry out FESEN and EDX study. So from this figure A here, it's showing that the FESEN of pristine graphene exhibit graphene sheets with irregular shape with the diameter of less than 100 nanometer. And then as can be seen from the figure B, this is the natural rubber where it shows a very smooth surface as we compare to the figure C, nanocomposite of natural rubber graphene. And through EDX, it's confirmed that there is no other elements that appear. It's just only the carbon and oxygen with a total of percentage of 100%. So means that it's showing it confirmed that there is no impurities that present in the composite. So we also carry out the X-ray X-ray photoelectrospectroscopy in order to investigate the graphene and natural rubber and all in the natural rubber graphene composite. So as we can see from as we can see from figure here, the C1 aspect of natural rubber graphene composite show high content of so higher intensity peak as compared to the graphene and natural rubber itself. So this is contributed from the carbon in the graphene and also a natural rubber. So this means that the majority of the carbon element come from the graphene that anchor in the natural rubber graphene composite. Okay, and for the Raman mapping scan, so there is three most prominent peak that we can that represent the graphene spectra, which are D, G, and 2D band. So this 2D band can be also there is a I mean like it's identical, or we can be seen in the natural rubber graphene composite, whereas invisible in the natural rubber. So from the ratio of intensity ratio of ID over IG and I2D over IG, we can obtain the multi-layer of graphene. So here's the electrical behavior of the natural rubber graphene composite. So as showing by the current voltage as characteristic. So as you can see from the histogram here, the conductivity is increased when we for the natural rubber graphene composite, as we applied the mechanical changes, for example, bending, stretching, and straining. So there is an increment in each of the mechanical change applied to the sample. So we also have another study for the to measure to study the electrical properties of the graphene. This is on the based on behavior dynamic response that applied based on the applied pressure on the natural rubber composite. So I just go for the very quickly on the resistive response. So the resistance response will decrease as the pressure is increased, and this indicate after the calculation we can show that the conductivity is increasing. So it means that as we apply the pressure sample from the rate of 0 to 22 kilopascal, the resistance is decreasing, and from the calculation we can notice that the conductivity is increased up to 3 millisiemens per meter. There is a much more increase in the conductivity as compared to the previous study. Therefore, this relative resistance change and the conductivity values of a natural rubber graphene composite is actually depending on the graphene content as a filler, and also on the pressure that we apply on the sample. So it demonstrates that this pressure research or work can shows the possible or potential to be for the fabrication processes of for the fabrication of the flexible tactile sensor that can suit for human machine interactions, and also for healthcare monitoring. So as a conclusions, we believe that a graphene rubber natural rubber composite can be equipped with some special functions or ability that can be used for more applications such as sensor, superheat insulator, and also can be extended for rubber application product in application area. And then this flexible electronic will be an important role in the field of security, entertainment, and also may lead to innovative applications in the near future. And I believe that since the demand on the preference of the flexible electronic, this product or production in the market, this product will be increased in yearly. So here is my previous team that was led by Professor Muhammad Rafi Johai, and also my committed research assistants. And I also would like to acknowledge the science fund for the grant from the MOSTI, and also the research university grant for University of Malaya, and also researcher from Malaysia Rubber Board, and also MIMOS for their contributions. And here's some reference that I'm using in my slide presentation today. So therefore, I would like to say thank you for your attention. I will willing to answer any question if there is a question from the floor. Okay, thank you very much.
Thank you very much, Ms. Afrin. Sorry, thank you very much, Dr. Malinda. Dr. Malinda, why I was mistaken. Okay, so now I open the floor for any questions you would like to ask Dr. Malinda about this graphene rubber-based composites. So you are most welcome. Any question from the floor?
Can I ask something?
Yes, Dr. Rika.
Thank you, Dr. Malinda, for the interesting talk. And actually, I am We know that graphene it can conduct electric.
The
And while
internet is quite slow near to the afternoon, so
okay, so can
I
you hear
might
me?
breaking in sometimes.
Oh, all right. So the question is, you are actually combining materials with opposite properties. One conducting electric, one as what we call for question name, the famous name. Macam kalau conduct one is
I think Dr. Rika is unable to connect, right?
what? Can you hear me, Dr. Malinda?
Dr. Laili, you still
We
can
can
hear
hear.
me?
I can hear.
I can hear both of you.
Oh,
I can
yeah,
hear
yeah.
Dr. Malinda and
Okay.
I also can hear Dr. Rika.
One
Sure.
conducting,
Okay.
one insulating. Yeah, sorry. One conducting, one insulating. So when you combine these two, you are actually trying to reduce the insulation punya properties and also the conducting properties of this composite, right? So what will be the potential, application for this nanocomposite?
Dr. Malinda, are you here?
Yes, I can hear you, but I can't
Okay,
hear questions.
Dr. Rika is asking about the application of this potential composite.
Oh, okay. So actually, we are planned to use for more like a tactile pressure sensor that's sensitive to human motion movement, like fingertips, any human motion movement. Because we actually in the first beginning stage, so we still need to study more on the properties of the rubber. For example, the edging properties, so we can see how their resistant percentage in order to be used for the longer time. So it's still in the beginning of the study of the natural rubber properties, natural rubber graphene based properties. So we are not we have that the application. I mean, like we have the, since we have the response on the resistive response just now I shared, but we still need to study in the characteristic of the material itself before we go further, because we need to have a very good materials in order to study further on the application part.
Okay, thank you, Dr. Malinda.
Thank you. Is that Dr. Rika?
Okay, so any question from anyone here? Maybe Ms. Intan, you want to ask anything to Dr. Nusiada? Dr. Nusiada and Dr. Malinda. Dr. Malinda highlight about your project on the PSA composite. Ms. Intan, do you want to ask any question to
Yeah,
Dr.
yeah.
Malinda?
Yeah, sorry for, yeah.
Oh, okay.
Yeah. Sure. Dr. Malinda,
Yes, please.
I just asked a very simple general questions.
Uh-huh.
If let's say based on your application for your material, right? The material based on your applications, if let's say if you don't want to use the graphene, is there any others alternative for your applications other than graphene? Is there any material crossing your mind that would be even better than graphene?
Yes, it's actually because people are actually move forward to the 2D two-dimensional material, right? So I have been thinking about the Maxine, for example, because it also has a good properties as similar as a graphene as well. So I'm looking for that kind of material as well in the future.
All right, it's okay. But I never, I don't mean that Maxine is only alternative, but I just wonder, maybe you have, I thought you may have a good, any alternative other than Maxine, maybe the others 2D material will be even better than the graphene. I'm just curious only, that's why I asked you. Okay, thank you, Dr. Malinda.
Okay, welcome.
Dr. Malinda, there is a question from...
There's a question from the chat box from Suresh Sagavdevan. So he wants to know more about what about the dielectric properties of natural rubber graphene composite. Can you please comment on it, Dr. Malinda?
Thank you, Dr. Suresh, for the questions. For these dielectric properties, it is because how to say it is like I cannot sorry Dr. Suresh, I cannot clearly explain at this moment. Maybe I can get back to you later on. Sorry, Dr. Suresh.
Okay, Dr. Sri and Dr. Melinda, maybe you guys can meet in the networking,
Yes, correct. Okay.
networking room, okay? So, is there any more question for Dr. Melinda? So Dr. Melinda, one question from me. So, how you confirm that distribution of the graphene sheets on your rubber matrix?
Okay, this one I'm using the actually graphene can easily be detected by using Raman spectroscopy. So we are using Raman spectroscopy uh, for the mapping and also for the normal scanning, and we can see that there is the existence of three significant peak that is prominent from the graphene spectra, which is D, 2D, and also D, G, and 2D band. And this is also appear in the natural rubber graphene composite. So which means if we compare to the natural rubber or pristine rubber, we cannot see this appearance of of this graphene pit. So we confirm by using the Raman spectroscopy and also an XPS.
Okay, so any more question from the floor? Okay, if not, so I would like to end the sessions. So before that, I would like to say thank you to everyone for your cooperation, from the IT community up to organizers, up to the and the presenter as well, the audience. Before that, I would like to make announcement for the best session presentation. So the best presenter for these sessions has been evaluated by the Dr. Yuziza, Dr. Rita, and me as well. So we decided to, it goes to the second presenter, Mr. Azam Muhammad Adnan. So can we give a big clap to him? Okay, so
Congratulations.
okay, so before and so I hope that all the participants can send your feedback to this given link, your feedback form. Please pick up your feedback forms, and uh, then thank you for everything. And on behalf of the community as well, I would like to say apologize if there's some problem regarding the technical and during the sessions. Okay, so thank you everyone. Okay. So we will
Thank you.
continue. You guys can continue to the networking room.
Thank you.
Thank you.
Dr. Yusliza.